Test for convergency of the series sigma n equal to 1 to infinity 2n minus 1 by n into n plus 1 into n plus 2. The expansion, the summation of these terms can be taken as the values. N equal to 1, we can substitute 2 minus 1 is 1 by 1, 1 plus 1 is 2, 1 plus 2 is 3, 1 into 2 into 3. Dot is nothing but multiplication, 1 into 2 into 3. Plus, when we can substitute n equal to 2, 2 to the 4, 4 minus 1 is 3 by 2 into 3 into 4. Plus 3 means 3 to the 6 minus 1, 5 by 3 into 4 into 5 plus so on. This is the given series. Okay. First we can take, let sigma un is equal to sigma n equal to 1 to infinity 2n minus 1 by n into n plus 1 into n plus 2. It is equal to 1 by 1 into 2 into 3 plus 3 by 2 into 3 into 4 plus 5 by 3 into 4 into 5. If they have given this series, then you can write in the expression of the n terms. Okay, then we can take here un is equal to 2n minus 1 by n into n plus 1 into n plus 2. Here we can take in the numerator n is common, that is 2 minus 1 by n by, in the denominator 1 is n, in the second factor 1 n common, in the third factor 1 n is common. Then it is 1 plus 1 by n into 1 plus 2 by n. 1 n get cancelled. It is equal to 2 minus 1 by n by n square into 1 plus 1 by n into 1 plus 2 by n. Okay. Here we can take the limit of un. We know that first limit n tends to infinity 1 by n is equal to 0. Limit n tends to infinity 2 by n also equal to 0. When we can take the limit value of un by vn. This is one, we have the condition of the limit of 1 by n, 2 by n. We know the limit values of this 1 by n, 2 by n, then we can easy to find out is it convergent or divergent. Next, here you can take un is equal to 2 minus 1 by n by n square into 1 plus 1 by n into 1 plus 2 by n. Here we can choose known series, that is sigma vn is equal to sigma 1 by n square. Here p is equal to 2, this is greater than 1. We can choose sigma vn equal to sigma 1 by n is convergent from p test. Then we can take limit n tends to infinity un by vn is equal to, or before of taking the limit, first we can find out un by vn. un equal to 2 minus 1 by n by n square into 1 plus 1 by n into 1 plus 2 by n by 1 by n square. This n square denominator n square get cancelled. We are getting 2 minus 1 by n whole by 1 plus 1 by n into 1 plus 2 by n. This is the ratio of un and vn series. Then we can take the limit n tends to infinity un by vn is equal to limit n tends to infinity 2 minus 1 by n in by 1 plus 1 by n into 1 plus 2 by n. After applying the limit 2 minus 0 by 1 plus 0 into 1 plus 0. It is equal to 2 by 1 equal to 2. This is the L value. It is not equal to 0. By comparison test, sigma Vn is equal to 1 by n square is convergent, then sigma Un is also convergent. Okay, this is totally depends on the p test. If np is greater than 1, then it is convergent. If p is less than or equal to 1, it is the divergent. See here the problems. How to find out the test for convergency series means sigma 1 by root n plus 1. Here we can take un is equal to the first solution. Un equal to 1 by root n is taking common 1 plus under root of 1 plus 1 by n. Okay, here you can choose sigma Vn is equal to 1 by root n. Then in the denominators, root n get cancelled. We know the limit value of 1 by n is 0. We are getting 1 by 1 plus root 1 is 1 by 2. It is not equal to 0. But here you can check this Vn any power 1 by 2. From the p-test, 1 by 2 is less than 1. So it is divergent. Then by the comparison test, it has a limit value. Then un is also divergent. Is it clear?
Yes, ma'am. It's clear.
In this, in second one, n is there. In the denominator, 1 plus n plus 1 whole power 1 by n. Here n is taking common. Then it will be n power 1 by n. No, here it is not nth root of not, it is nth root of n plus 1 is, it is not correct. This is n into root n plus 1. Then here we can take n power 3 by 2 is common here. N by n power 1 here root n. N power 3 by 2 is common here, 1 by n root n plus 1 by n power 3 by 2 into here 1 by n root n plus n is outside, root n is also outside, 1 plus 1 by n under root. Here 1n, here minus 1. That is nothing but 1 by n power 1 by 2 into 1 by n power 3 by 2 plus under root of 1 plus 1 by n. We can choose again here Vn equal to 1 by n power 1 by 2. Here 1 by 2 is less than 1. So Vn is divergent, then Un is also divergent. Okay.
Yes, ma'am.
Third one. Here first we can take the Un. Un is equal to summation of n plus 1 minus root n. Un is without sigma Un is this one. From this Un is equal to under root n plus 1 minus root n. We can take the rationalize under root n plus 1 plus root n by under root n plus 1 plus root n. It is equal to n plus 1 minus n by root n plus 1 plus root n. This is equal to 1 by, in the denominator taking common root n, that is 1 plus under root of 1 plus 1 by n. Here also Vn is equal to 1 by root n. Sigma Vn is sigma 1 by root n. That is nothing but sigma 1 by n power 1 by 2. Here also 1 by 2 is less than 1. Vn is divergent, then Un is divergent. Like that we can take here. In the fifth one, fourth one later I can discuss. In the fifth one we can take in the denominator n power, here n power 3 by 2 is taking common. We can choose Vn equal to 1 by n power 3 by 2. Here 3 by 2 is greater than 1. This is convergent. Then by the comparison test, it is also convergent. Got it? Okay, Adarsh?
Yes, ma'am. Yes, ma'am. I'll try the other two on my own, ma'am.
Okay.
Like the last two.
In the sixth one, in the numerator root n common, in the denominator n square common, that is 1 by 1 plus 1 by n square. Here root n means 2 minus 1 by 2, that is 3 by 2. Okay, this is taking to denominator, it is 1 by 2, that is 3 by 2 in the denominator of n power. In this, sigma Vn can be choose sigma 1 by n power 3 by 2. Here 3 by 2 is clearly greater than 1. From the p test, it is the convergent, then this is also convergent. Got it idea?
Yes, ma'am.
Here in the numerator, n is common. In the denominator, n cube is common, 1 plus 2 by n cube. 1n cancel, n square. Taking outside 1 by n under root of 1 plus 2 by n cube. Here it is un term. What we can choose? Sigma Vn is 1 by n. Here n power is 1. Here p equal to 1. So it is divergent from the p test. Then un is also divergent. Okay.
Yes, ma'am.
The fourth one, what should we can do means first we can write it is an in the nth term. What is the nth term of this series? Sigma un is equal to, if sigma n equal to 2 to infinity, if we can take root n minus 1 by n plus 1 whole square minus 1. From this un equal to root n minus 1 by n plus 1 whole square minus 1. Here in the un, in the numerator root n common, 1 minus 1 by root n. In the denominator n square common, 1 plus 1 by n whole square minus 1. Actually n common, n square is n whole square is n square. It is equal to 1 minus 1 by root n by n power 2 minus 1 by 2. Why? Because root n is nothing but n power 1 by 2. It is taking to denominator. 2 minus 1 by 2 is 3 by 2. This is 1 plus 1 by n whole square minus 1. Okay.
Yes, ma'am. Understood.
Vn is convergent, then un is also convergent.